Okay, physics. We're going to go through this process of trying to figure out the mathematical equation for some data set, and we'll do a process called linearization, where the idea is that basically if we can make it into a straight line, then we can get an equation from a straight line. So the equation is y equals mx plus b. So what we'll try to do is manipulate the data and make it into a straight line and then pull that equation off. This is simpler than it sounds, because we're only going to have really 4 or 5 different relationships that can exist. So these are the relationships that exist. So this is in a handout that or posted in a document that you have access to. So you might find this and reference it whenever you're doing these graphs, especially at the beginning. So the first one, so if there is no relationship, so if it doesn't matter what x is, y is always going to be the same. Then you'll get a flat line or a graph which has no slope to it, so it has a slope of 0. Right. So this means y and x don't have a relationship, and mathematically, what that means, it means that y is always constant. Right? So next most simple equation is where we have a linear relationship. So if I plot x and y and I get a good fit to a straight line, then I'm golden, right? So I can use the y equals mx plus b to be able to make that into an equation. When I plot something, so if I'm plotting, I don't know, air pressure versus volume, that when I plot that, whatever I put on the y-axis is what's going to show up in my algebraic expression, right? So when I'm making an equation, the letter y should never show up. It should be something that you were plotting, and whatever it is that you were plotting on the y-axis is the thing that should be there. So if you're plotting volume on the y-axis, that y should represent volume. If you're plotting time on the x-axis, then x should be t for time. So we get an equation that looks like y equals mx plus b, but you never have y, and x is seldom used. So those are 2 straightforward ones, and we can have 3 different shapes of curves that you may come across. And then I'll need you to know these 3 different shapes, and these are the only 3 things you're going to worry about. So you're going to have this decreasing shape, so it's inversely proportional, in which case it's going to be an inverse relationship. I can have a curve that increases like this, so this is going to be a square function, and I can have a plateau like this third one, which is going to be a square root function or the square of y. So what we're going to do is we're going to turn these last 3, we're going to turn them into a linear graph. And the way that we do that is I'm going to graph, in this case, I'm going to take all my x values, and I'm going to calculate 1 over x, and then I'm going to replot, make a second graph, which is going to be y versus the 1 over x. And when I do that, I should get a straight line, and when I get a straight line, then I can use y equals mx plus b, but instead of x, it's going to be 1 over x, so I have to be careful how I write it. Same idea for if a graph looks like this one, I'm going to say, oh, well, let me recalculate. Instead of x, I'm going to plot x squared. So I'm going to take all my x values, I'm going to square all those x values, and I'm going to make a graph, which is my original y against my new value of x squared, and when I do that, I should get a straight line. And when I get a straight line, then I can use this y equals mx plus b, but be careful, it's no longer x that we plotted, it's now x squared. And similarly, that if the y value needs to be squared, I can replot that and get a straight line, and now I'm plotting y. And when I pull my equation off, I'm getting y squared. So these are really the 5 relationships that we'll come across, right? There is no relationship, which happens every so often. It's a linear relationship, it's an inverse, is proportional to the square of x, or is proportional to the square of y. Those are the only 5 things that you're going to come across in this class. So if you want to make something more complex, so some people like doing polynomials and things like that, just stop, don't do that. So pick one of these 5, and whichever one is closest, run with that one. So let me show you what this looks like. So here's what this looks like. So I pulled up this data set. So volume versus pressure, and I don't know what it's going to be. Well, I do know, but I'm not going to tell you. So this is how I'm going to go about it. So I'm going to graph it, right? So first thing I'm going to do, I'm going to highlight that. I'm going to insert a chart, and then my chart is going to be the wrong kind. So I don't want a line chart. I want a scatter chart. I'm going to check my x-axis is correct. So I wanted volume on the x-axis, sure. And my y-axis or series is pressure. That's correct. I'm going to check to make sure they didn't mess up my horizontal axes, so it's not treated as a label. I'm good. And now I'm going to look at this and I'm going to say, well, what does this look like? I can fit a curve to this. Series, trend line, like it fits, and it doesn't. It's not linear, right? It's some sort of exponential. I don't know. I can always get a polynomial too. I don't know. It's logarithmic. I don't know. Power series. Who knows what that is, right? So this I can get something to fit, but it's not a straight line, right? So I'm not exactly sure what it is. So what I'm going to do, I'm going to drag this out of the way. I'm going to look at the shape of this curve, right? So what does this look like? Well, this shape of this curve, well, let's go back to here and see. So which one does this match? So to me, it looks more similar to this. Right? So what am I going to do? Well, I'm going to grab y versus 1 over x. So I'm going to recalculate my x value as 1 over x. Well, let's do that. Right? So I'm going to go here. I don't want this. I'm done with this. Well, I'll save this for later. Why not? So save it for later. Reference. So I'm going to have the same y value. So I'm going to make a copy of this. So if I highlight all of this, try Control C. I'll just make a whole new one over here. Control V. I'm going to Control C. I'll have the title be the same. Well, actually, I'm going to rewrite this, right? So this isn't pressure, right? This is 1 over pressure, right? Capital P. And here's the magic of using a spreadsheet, right? So this is the strength and the benefit of using a spreadsheet is that it'll do the calculations for me. I don't have to have a calculator and do it. So I'm going to hit the equal sign. So equals takes me to this. I'm going to type 1 and then divide by. And then I'm going to click on the cell that I want and hit enter. Right? So note it did the calculation for me. So if I highlight this cell up in this upper left-hand corner, you can see this is the calculation that it's due. And I said equals 1 divided by that cell, turns out to be C18. Then when I hit enter, it did the calculation for me. So I can do that calculation again and again the same way, or this is the magic. Ready for it? This is a little square down here. I'm going to drag this square and it's going to automatically do all those calculations for me. Shazam, I'm done. Math, right? Math is easy. So now what I've done is I have my old y values and my new x values, which are 1 over x. And now I'm going to make a graph of that. And let's see what it comes out to. So I'm going to make a graph of this. So I'm going to insert a chart. And I'm going to do a scatter plot. Oh, super. Got it right. It's got volume on the x-axis. Super. It's got 1 over p on the y-axis. Huh. Is that what I want to do? I want to graph 1 over x. Well, okay. Little secret, right? You'll get the same answer in this case either if you do 1 over x over 1 over y. Let me go back though. I'll fix it. Let me undo this. So I'm going to get rid of this. Delete. So I want to put 1 over x. X comes first, right? So I'm going to copy all of these. Copy, paste. I'm going to have 1 over x, so it's 1 over volume. And this is going to be equal to 1 divided by this. There we go. And now I can blue dot it and drag that blue square down, and I get something that looks like this. Okay, so now I've done what I should have done the first time. It'll work out either way in this case, though. So now I have 1 over v, 1 over what I had previously on my x value, and pressure remains unchanged. So now I'm going to insert a chart, do a scatter plot, and now I have 1 over v on my x-axis. I have pressure on my y-axis. Let me double check to make sure it didn't mess up the horizontal axis, so it is not treating them as text, so that's good. Let's go fit a trend line. I'm going to scroll, let's go to series and then trend line, and oh, look at that. That looks like a great trend line. So I'm going to have it show the equation for this and the r squared value, and because it's fake data, it comes out very good, right? So now I can write an equation. What's my equation going to be? My equation is not going to be pressure equals 4 times x. My equation is going to be pressure is equal to 4 times 1 over volume. Right? So let me be careful about that. So now my pressure is going to be equal to 1/4 times my volume. Sorry, 4 times 1 over my volume. Right. So, so this is called linearizing. So we're taking something which is nonlinear. Remember, it looked like this, which is a curve, and I'm getting an equation out of it. So my equation that I get out of it at the end is y equals mx plus b, but y equals mx plus b. But I manipulated the x-axis to get 1 over volume. Again, as you saw, that once you get comfortable doing this in sheets, that it's really straightforward and it's easy. You can try all 5 or all 3 different manipulations that you might have to do and see which one gets closest. It's not super time consuming if you get comfortable with sheets, so it's worth putting a little bit of effort in to get there. So that's the next idea. So we'll come across data sets, and I'll give you some to try, where you'll be able to figure out a mathematical representation for that using linearization. I'll ask you to show me both the original graph and then the linearized graph, and then pull the equation off of there. And the equation should not have y in there, and it should represent the mathematical manipulation that you did to whatever axis that it was, right? So remember, what I got to in the end was my pressure is 4 times 1 over the volume. So that's an equation that represents the data set. Great, hope it's helpful, and I'll talk to you soon. Bye.